I'm gonna do a pretty simple question to start the day off. By the way, I don't know why this is here, but you see this mole liter per second? This is a chemistry. This is the rate of change of a chemical reaction. Like how fast does let's say how fast does oxygen burn in air or something. This is the unit of it, basically, mole per liter seconds. Don't worry too much about it, though. As you can see, math is behind a lot of other sciences as well. Even biology, you might think, well, does math have anything to do with it? It's prevalent even in biology. Let's look at this question. Right, the goal is to simplify this. What is our plan of attack? Can we cancel out anything right now?
No.
So what do you do in a thing like this? What you do is, again, you don't have to do this, but the ideal way to do this is I'm going to group up all the numbers, the constants. I'm going to group up the x's, and I'm going to group up the y's. Then it becomes much easier to see what it is, right? Like that. 5 goes into 15 3 times, right? 2 goes into 8 4 times. 2 goes into 6 3 times. So our constants, the numbers, they simplify to 3 times 3 over 4, 9 over 4. Yeah? Look at this. On the top here, we have x3. On the bottom, we have x2. What does that simplify to? x3 over x. Yeah, just an x. What about the y's? We have 3 on the top and we have 5 on the bottom.
Y2?
On the top or on the bottom?
The bottom?
Yep. And you're done. Easy peasy. What are the restrictions? What can x not be? What can y not be?
Y can't be 0?
Yeah, what about x? Notice x is in the denominator as well.
It also can't be 0?
Yeah, exactly. X and y can't be 0. And you're done. Okay? What if instead of x it was something yada 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 over x minus 1? Then what can x not be here?
1.
Okay, what if it was x minus y? What can x not be?
Y.
Yeah. So there you go. That's all there is about the restrictions. Okay, so this one, it's a bunch of things going on, but it's not too bad. What's this in the form of? What can we do with this? Can we factor that right now?
This.
Yeah, difference of squares. What does that factor to?
X minus 2.
X minus 2 times x plus 2. The bottom one, it's already factored as it is, so you don't have to touch that. This one, quadratic trinomial, what does it factor out to?
It multiplies to 18, adds up to 9.
What are the numbers? Do they exist? They do exist. Just think about what multiplies to 18. There's only two things that multiply to 18. Two permutations, I guess. One of them is 9 and 2. That one doesn't work. What else multiplies to 18?
Um, 6 times 3.
Yep, 6 and 3. How do we factor that then? What does that become?
You replace it with 9x.
No, you don't have to do that because you will do that if there is a leading coefficient. But if the leading coefficient is 1, the shortcut is you just take those numbers, x positive 6, positive 3, like that. That'll save you a step. But
Okay.
if the leading coefficient is not 1, like if it was 2x squared, then you would want to break down the 9x's. Now, yesterday I told you a little trick. 2 minus x and x minus 2 are kind of related. We can change one into the other. What's a little trick?
You put the negative sign in the front.
Yep, so it's going to be 2 times negative 1 or negative 2 times x minus 2. Right, like that?
Mm-hmm.
And things always cancel out. X minus 2 gone. X plus 6 is gone with one of the x plus 6's. Anything else? No, right? That is it. So you get x plus 2 times x plus 3 over negative 2 times x plus 6. Now, when it comes to restrictions, you also have to take into account the things that you canceled out. So what are the restrictions here?
X can't be negative 6 over 2. Negative 2.
X can't be negative 6, okay? Or positive 2. Is that what you said?
Uh-huh.
And yeah, that is it. Easy peasy, right?
Mm-hmm.
Okay, trick question. What's the point of this? Why did we do this? What does this tell us? Tells us a bunch of things. Even though this is not a polynomial per se, but there's a polynomial on top and on the bottom. Tells us the zeros. The zeros of this function, okay? To find the zeros, once it's simplified, you set the numerator equal to 0. So the 0 of this function is at negative 2 and negative 3, okay?
Mm-hmm.
It tells us where the vertical asymptote is, because if you get a 0 on the denominator, like here, you get a vertical asymptote. But if things cancel out like this, the restriction that we got from canceling things out, that's a hole in the curve. So it tells us a bunch of things. So we can even graph this right now somewhat. So we know there's a negative 2, negative 3, there's an x-intercept. We know there's a vertical asymptote at negative this, and at 2 somewhere there's a hole, right?
Mm-hmm.
What this looks like, it's anyone's guess. Maybe if we had the y-intercept, y-intercept would be 6 over negative 12 or negative 0.5. So like that. So this could look something like this. That's just one possibility. Cool. So it
Uh-huh.
tells us a bunch of things, right? That's the whole point of simplifying it. Same kind of idea, but a little bit more annoying. Um, hmm. Can we pull anything out here? Is there a GCF between those two?
3p.
Um, okay, we can do 3p, or we can do negative 3p. Which one would be better? I'm trying to think. If we do negative 3p, I'm gonna switch them around as well, like this. Usually it's better to write it in descending order from the highest power. So negative 3p would be p minus 7, right? You agree with that? p minus 7. But later on, if we see something like 7 minus p or something, we can throw the negative sign back in there. So let's stick with this for now. What about on the bottom? What can we pull out?
4p.
Yeah, what are you left with?
P plus 4.
Yeah. Division, we're going to turn this into a multiplication every single time. So these are going to flip-flop. This is going to go up there. That guy is going to come down here. Look at this quadratic trinomial. Multiplies to 12, adds to 7. What are the numbers?
3 and 4.
Yeah. So straight up, p plus 4, p plus 3. What about the other guy? What are the numbers for that one? Multiplies to 14, adds to negative 9.
-7 and -2.
Yeah, negative 7 and negative 2. So you have p minus 7 and p minus 2, right? Now hopefully things cancel out. P and p cancels out. P plus 4 cancels out. P minus 7 cancels out. Therefore, your final answer is going to be 3 times p plus 3 over 4 times p minus 2. Okay? What are the restrictions? There's a few of them here.
P can't be 2.
P can't be 2. Yeah, that's right. That's one of them. Anything else?
It can't be -3.
Okay, so that one is, but it's in the numerator, right? Can we not have a 0 in the numerator? I think you kind of fluked this one. Yeah, it's -3. But only because this is a division here. What happened is that this term was initially in the denominator, so you have to account for what you had before as well. But let's say this is not this is a multiplication, then no, it would not be -3 because you'd get a 0 on the top. Getting a 0 on the top is fine as long as it wasn't a 0 to start off with, but it is in this case. So yeah, it's -3. This one's a 0. It's +7. It's -4. And it's also a 0. There you go. It has a bunch of restrictions. Do you understand what happened? This one's pretty obvious. P can't be 0. This one, P can't be -4. This is normal. 7 is also normal. It's in the denominator. +2 is also normal. It's in the denominator. A lot of people forget about the -3 because they don't account for where it came, right? Because -3 was on the bottom to begin with. So yeah, you have to work all the way backwards. For this one, there's 5 different. Let's see if they agree with us. 1, 2, 3, 4, 5. Yeah, there we go. Does that make sense? Because that's how they trick you sometimes with the restrictions. Is there any word problem available? Okay, there it is. So it's a triangle, and they want us to find the area in simplified form. How do we go about doing this? Any ideas? What's the formula for an area of a triangle?
Length times width over 2.
Right, or better yet, base times height over 2. Because what's the length? What's the width in a triangle? Base times height over 2. So yeah, let's just do that, and hopefully we get something that we can work with. So base times height all over 2, yeah?
Mm-hmm.
So base, we can pull out a 5 there. We're left with x minus 7. What about this guy? What does that factor out to? It's a quadratic trinomial, right? In the denominator. No? Well, yeah, actually that's pretty tricky. But it's not though. If you know your tables, if you know your 7 tables, it's not that bad. Multiplies to 63. There's only one thing that multiplies to 63 of numbers that are less than 10. One of them is 21 and 3. That one doesn't count. What else multiplies to 63?
7 and 9.
Yeah, exactly. Adds to negative 16. Negative 7 and negative 9 does add up to negative 16. So there you go. So x minus 7, x minus 9, right? Like that. Does anything cancel out? Yes, it does, right? This one and this one cancels out. Yeah?
Mm-hmm.
So we're almost done. Where does the 2 go? Does it go to the second level or does it go to the top? It's gonna go to one of those.
The second.
Yeah, it's gonna go to the second level. So your final answer is gonna be 4x squared times 5, I guess. 4 times 5 in the numerator is 20x squared. On the bottom we have 2 times x minus 9 times x plus 3. What are the restrictions?
X can't be negative 3 or 9.
Okay, are you missing any? You're missing one. If you also have to account if it canceled out.
It can't be 7.
Yep. And you're done. Okay.
Mm-hmm.
Not gonna do that. Let's do a simple addition. 1. Straight up, what's the restriction? Because it doesn't matter what we do when we add or subtract them, it's not gonna change because nothing's gonna cancel out.
X can't be 0.
Yeah, straight up, x can't be 0. What's the LCD here? What's the LCD between 8, 4, and 6? Is it 12? 16? 18? What is it?
24.
Yeah. What about the x's? We have x2, x, and x3.
Is it X3?
Yeah, it is. So our LCD is 24x3, meaning this one needs a 4. This one needs a 3x. What does the middle guy need to get 24x3? I need to multiply 4x by something to get 24x3.
6X?
6x will give you 24x squared. We need 24x3.
6x squared.
Yes, 6x squared. I'm just going to do this in one step. 3x times 3, 9x. 1 times 6x squared, 6x squared. 5 times 4, 20. All over 24x cubed. Right? And that's it. And x can't be 0.
Mhm.
This could potentially be factorable, but I'm not worried about that now because it's going to be too big, right? Because 20 times 9 or 20 times 6 is 120, and 120 is a really nice number in terms of having factors, right? Like, check it out. What do I mean by really nice numbers? These are numbers that could potentially give a lot of issues. Look at the number 24. It's divisible by 1, that doesn't count. It's divisible by 2, 3, 4, 6, 8, 12. You see that? It has like 6 factors. It's a very nice number. 120, the number that we came across here, 20 times 6, that is divisible by 24. So that means this one probably has a lot more factors. Okay? It's divisible by all of these, plus it's divisible by 24. And what else? 5, 10, 20, 30, 40, 60. You see that?
Mhm.
These are numbers that can give a lot of problems when it comes to manning it because there's just so many permutations of what times what. Yeah, so if possible, avoid those. Sometimes actually, because manning is efficient only if you can come up with the numbers quick. If you can't come up with the numbers, quadratic formula can be quicker sometimes. Especially like, yeah, 120 is bad, but something like 2400 is worse. You see that? Because
Mhm.
that's all 120 applies to this, plus so many much more. All right, let's look at this one. What is the LCD? We're adding two different things. If you're ever unsure about LCD, you multiply them. That is always going to work. It won't be the lowest common, but it'll still give you the right answer. You just have to like simplify it maybe at the end. Any ideas what the LCD could be in this case? You just multiply them, right? You just multiply them together. It's going to be 2n plus 1 times n minus 3, like that. So that means this one is lacking n minus 3, and this one is lacking 2n plus 1. If we FOIL the first guy, what do you get?
3n squared minus 9n.
Yeah. What about if you FOIL the other bracket, this one?
Eight n plus 4.
8n plus 4 works. So then you have minus 9n plus 8n is minus n, yeah? What about for this one? What does it multiply to? Let's see if we can man this.
It multiplies to 12. Adds up to 1.
Not 1. Try again.
Negative 1.
Negative 1. What are the numeros?
Negative 4 and 3.
Negative 4 and 3 works. And now there is a leading coefficient. It is no longer 1, so there's no shortcut. So we have to do this on the side. So 3n squared plus 3n minus 4n plus 4. Notice how I wrote the 4 with the 4, the 3 with the 3 to make life easier, right?
Mm-hmm.
So you can pull out a 3n, you're left with n plus 1. Take out a 4, you're left with n plus 1. So what does that thing factor out to? We n plus 1, right? Times 3n minus 4. Do you agree with that?
Mm-hmm.
Anything cancel out here?
No.
No, this one and this one do not cancel out. There's a 2 there. What are the restrictions?
N can't be 3.
Anything else?
Negative 1/2.
Yeah, and you're done. Easy. They didn't even factor this out, but that's okay. It's always good to factor it out just to see if it cancels it out. The book doesn't always do what it's supposed to do, but that's okay though, as long as you get the right answer. Have you seen this? What is this? See this diagram here? What does that look like? Surely I don't expect you to know. This is
I assume we're gonna do it in science.
not yet. You'll do it in grade 11, I think. This is a circuit board. You see this plus minus? This is your battery. And then you see these arrows, that's the direction of the current that's flowing in the board. Like on your phone or something, this is what's happening right now. You see these squiggly mountain type lines? These are resistors. So yeah, don't worry too much about it, but it's fun. You're gonna hate this when you have to learn it because what happens is you need to find the net current or the net voltage. Voltage is just another word for battery in a system, and it can get pretty annoying pretty quickly. Let's do something that you're gonna see in class tomorrow, hopefully. Something similar to this. So there's 3 girls, and their ages are a function of n. The question says, are they triplets? How can we deduce this? What you can do is just simplify them, right? Just clean them up, see if they are the same. If they are the same, then what does that mean? That means they are all of the same age, yeah?
Mm-hmm.
So yeah, they will be triplets. If not, they won't be. Make sense?
Uh-huh.
So let's clean this up. Let's open the first bracket here. This negative sign applies to the n. It also applies to the 30, like that. Collect like terms. What does this simplify to? Negative n plus 2n is what? You lose 1 apple, right? You gain 2 apples. How many apples do you have? 1 apple. Same idea. Negative n plus 2n is n. Okay?
Uh-huh.
What's negative 30 plus 5?
Negative 25.
Yes, easy as that. Well, now we're gonna do the same thing for the other two daughters. It's not too bad. It's gonna be like a 10-second answer. So again, whenever you see a negative sign here, you see that? You need to put this guy in a bracket and you need to flip all the signs inside of it. So when you FOIL this with a negative sign, you get negative 32 plus 4n, yeah? 7 minus 32 is negative 25. What's negative n plus 4n?
3n.
Yep, so 3n. So they're definitely not all triplets because at least two of them are different. Now we're going to do the same thing for the third one. N minus 26, again, negative sign and a bracket. You need to flip all the signs here. Minus n minus 4 plus n minus 3, like that. We have n minus n plus n, that's just an n. Negative 26 minus 4 is negative 30. Minus 3 is negative 33. Cool? Are any of them triplets?
No.
Are any of them twins?
No.
How old was the mother when Cassandra was born, when this lady was born? So when she was born, how old was she? 0 years old, right? This function gives you Cassandra's age in terms of her mother's. So it's asking you how old was the mother? You said that Cassandra's age equals to 0. She was 33 years old. Cool.
Okay.
This is actually kind of funny. Wait, did we do this right? We did. So what's going on with the second girl? How old was the mother when this lady was born? The first one makes sense, 25. This one is sketchy though. 25 over 3, what is that, 8.33 years? I don't think they accounted for that. Or maybe I messed it up. No, I messed it up. Negative, negative, how did that? This should have been a 2. This should have been an n. Yeah, there we go. So there are twins. So yeah. Sometimes if something seems so out of field, like here, see this? I noticed this n is gonna be less than 10. So yeah, either the question is whack or we did something wrong. Turns out the question was okay. I didn't add up the 2's properly. So yeah, there's twins. A and B are twins. All right, the volume of a cone is given by this. Without the over 3, that's a volume of a cylinder, right? Pi r squared h. But if you divide that by 3, you get a volume of a cone. Divide the volume of a cone, determine if the radius increases by x and the height increases by 2x. Interesting. What is our approach going to be here? It's not that bad, right? So if the radius increases by x, what's the new radius? It's going to be r plus x. If the height increases by 2x, what's the new height?
H plus 2x.
Yeah, h plus 2x. So the volume of this cone is going to be 1 over 3 times pi times r squared, so r plus x squared, yeah? Times h, which is h plus 2x, like that. Cool? We can open this, I guess. Yeah, I'm gonna FOIL this with the h term first. Because it says in simplified form, that means they probably want it FOILed. So I multiplied this in there, I got that. Do you remember what the formula was for a plus b whole squared? You know, difference of squares, that one's pretty simple, but this is like a whole squared.
No.
This is a squared plus 2ab plus b squared. Or you can FOIL them as well and add them up, but this will save you 10 seconds, 15 seconds. Probably will save you a long time over your studies. So this is the formula. If it's a minus b squared, then it's a squared minus 2ab plus b squared. They don't teach you these, but this is how it works. So I'm going to use that to FOIL this. Look at this. A is r, so you get r squared plus 2ab, so 2rx plus b squared plus r squared, like that. And then you FOIL it. There probably won't be any like terms. You're multiplying 3 terms with 2, so there's going to be 6 total terms in your final answer. So pi h r squared plus, I'm going to do this guy with the second guy. What is that? When you multiply them, what do you get? So 1 over 3 times 2 is 2 over 3, right?
Mm-hmm.
Pi h times rx, they have nothing in common. Pi h rx. The third term, again, there's an x, there's a pi, there's nothing in common. So 1 over 3 pi h x squared. Now we do this with this, right? Again, there's nothing in common, so you just rewrite it. 2 pi x r squared over 3. This one and this one. 4 over 3 r pi. They both have an x, so you get an x squared. What's the last term? What's the final term? We're gonna do 2x pi over 3 times x squared. What does that give?
Do you just get 2x to the power 4 times pi over 3?
2x cubed pi over 3, and you're done. Okay,
Okay.
that was annoying. There's a lot of terms in there. Where's the triple one? All right. This one's gonna be pretty annoying. But it can be done pretty quickly as well because notice none of them have leading coefficients. So we can factor them straight up. Look at the first guy in the numerator. That's a man question. Quadratic trinomial. What does that factor out to? Any ideas? It multiplies to 6, adds to -5. What are the numbers?
-3 and -2.
Yep. So again, the leading coefficient is 1, so you get x minus 3 times x minus 2. What does the bottom factor out to?
X minus 1
That's it? Or is there something else?
times x plus 1.
Yeah. What does the next numerator factor out to? Multiplies to -5 and adds to -4. Does it exist?
-5 and 1.
Yeah. X minus 5, x plus 1. What about this denominator?
X minus 2 times x plus 2.
Yep. Easy peasy. The division, flip it upside down. X minus 5 comes here. X squared plus 3x plus 2. That's x plus 2, x plus 1. Okay?
Mm-hmm.
A bunch of things are going to cancel out. This is the best part. X plus 1, x plus 1. X minus 2, x minus 2. X minus 5, x minus 5. And that should be it, unless I did something wrong and I did. This should have been x plus 2. So this one and this one is also gone. And that's it. X minus 3 times x plus 1 over x minus 1. That's all that remains from all this. What are the restrictions? That's going to be a little bit tricky.
X can't be 1.
Yeah, 1 is good. Is that it?
X can't be 2.
Yes.
It can't be 5.
Yes.
X can't be negative 2.
Yes.
It can't be negative 1.
Yes. Plus minus 2, plus minus 1, and 5. And then you also got to account for this, because that was in the denominator, right? This guy.
Mm-hmm.
But it's already been accounted for. Negative 2 and negative 1. Yeah, there we go. So it has 5 different restrictions. It's pretty annoying, yeah? Let's try another one. Okay, again, there's a bunch of trinomials. We don't like trinomials, so we're gonna try and converge all of them into their simpler factored forms. So the first numerator, you can't do anything with it. What does the denominator factor out to? So we have b squared minus 2b whatever, right? Any ideas? We're just trying to factor that denominator. The first one. So b squared minus 2b minus 15 multiplies to negative 15, adds to negative 2. It's negative 5 and 3. Yeah?
Mm-hmm.
B minus 5, B plus 3. Plus 3b, you can't do anything with it. The next one multiplies to negative 30, adds to 1. It's b plus 6, 6 and negative 5. We'll give you that. Times, what about this one? Multiplies to 12 and adds to 8. Does that exist?
Six and 2.
6 and 2 works. So again, you have b plus 6, b plus 2, all over b plus 3, like that, right? Let's see if anything cancels. Again, you have to use the BEDMAS. You can't add them up first because BEDMAS. If something is being multiplied, gotta deal with that. So here, this and this cancels out. Nothing else cancels out. You can FOIL that bracket. And all over b plus 3, b minus 5. Actually, this one worked out because they have the same denominators. If you notice, whatever we're left with, it's the exact same, yeah? So we can straight up just add the numerators up. So you get 3b squared, the biggest power. Then we have 6b plus 2b, which is 8b, and minus 5, like that. You have b plus 3, b minus 5. What are the restrictions?
-3 and 5.
There's one more. So take into account what you canceled out.
-6.
Great. And you're done. Cool.
Mm-hmm.
Is this hard?
No.
Let's see what else we can factor out in terms of polynomials. We've done that. Okay. I'm gonna do this thing, but we're gonna use ideas that we've learned in the derivative chapter. What type of a function is h of t? What would it look like? Is it a quadratic?
Yes.
Is it opening up or down?
Down.
It's opening down, right? So does it have a maximum or a minimum?
A maximum.
Right? How do we find this maximum? What happens? What's so significant about this maximum? Something is 0.
The slope.
Yep, slope of the tangent. So let's find the slope function. So if ht is that, what's h prime of t? Find the derivative of that t thingamajig.
-10t plus 20.
Yeah, -10t plus 20. Now what's the slope? The slope is 0, right?
Mm-hmm.
And this will give us the time, because the x-axis, always time. Y-axis for this one is height. So -10t equals -20. T will be 2 seconds. So we know the maximum height happens at 2 seconds. How do we go about finding the y value of this? What the maximum height actually is? All you gotta do is you gotta plug that time that you found, right? The x value of 2 back into the equation, okay?
Mm-hmm.
Because we know at time equals 2, there's a turning point, there's a maximum. So to find the maximum height, you just plug this back into the equation. Or in other words, you find h of 2. So I'll get -5 times 4 plus 40 plus 50. 90 minus 20 is 70 meters. And you're done. Okay? So the maximum height is 70 meters. Part B, how long does it take for the ball to reach its maximum height? In other words, how long What time does the maximum height happen?
At 2 seconds.
Yeah, at 2 seconds, right? So t is 2. C, how high is the rooftop? So we're firing a ball from the rooftop. This is the rooftop. How high is it?
50.
Yes, that is all there is. At 50 whatever meters, the ball was shot from. Here's another question. Again, a bunch of words. They've given you C and they've given you X. The question's asking you determine the minimum production cost. Again, it looks difficult, but it's not. What type of a function is C of X?
A quadratic.
Opens up or down?
Up.
Yeah, so is it gonna have a minimum or a maximum?
A minimum.
Right. What's gonna happen at the minimum? What's significant about it?
The slope is 0.
Exactly. They've given us Cx. Let's find C prime of X. So again, bring the 2 down. What's 0.28 times 2? What's the derivative of negative 0.7x?
Negative 0.7.
Yeah, negative 0.7. And we know this is the slope. Slope at the minimum will be 0, like that. So you get 0.56x equals 0.7, right?
Mm-hmm.
So x will be 0.7 divided by 0.56. 0.7 divided by 0.56. That gives us 1.25. So is that the final answer here? 1.25. Actually, no, they want the cost. Cost is the y value. So again, like we did in the previous question, x is the number of items, so this is the number of items. We need to plug this back in there as x to find the cost. So C of 1.25 is all we need to find. So 0.28 times 1.25 squared minus 0.7 times 1.25 plus 1. So that gives me 0.5625. So is that the answer to this question? $0.56? Are we done? Or is there a catch?
Doesn't the answer have to be in millions?
Yeah, so the answer is $0.5625 million. Or in other words, you can multiply that by a million, which is a 1 with 6 zeros, $562,000 and $500. So there you go. That's the minimum production cost. Yikes, that's a lot. I mean, we don't know how big this company is, this plant is, so maybe it's not a lot, but for a minimum, I guess that is a lot. This one is like a trick question. We know it's a quadratic that opens up, right? It has a
Mm-hmm.
y-intercept of 5, and it says this cannot be less than 1. So that means the minimum value, yeah, has to be greater than 1. How do you prove this? You have to show that the minimum value is greater than 1. Minimum and maximum, they always mean the y values. How can we show this? Again, it's just worded differently. We just do what we've been doing for the last 2 or 3 questions. What's going to happen at the minimum value?
The slope is 0.
Yeah, so if this is y, we can find y prime. What's y prime?
6x minus 6.
6x minus 6 is right, and we know this is a slope function that will be 0. So 6x is going to be 6, x is going to be 1, right? So when the x value is 1, we get a minimum value. How do you find the minimum y value?
plug 1 into the equation?
Yeah, you plug 1 into the equation. Do not plug it into y prime. You have to plug it into y because we're trying to find the minimum of y, okay? So you get 3 times 1 minus 6 plus 5. So what's this? 3 plus 5 is 8, minus 6 is 2. So the minimum y value occurs at 1 comma 2, right? So this is the minimum. The minimum y value is 2. That's why it can never be less than 1. Could this have x-intercepts?
No.
No, it cannot be, because to have x-intercepts, the y value must be 0, and we know for a fact that it can't be less than 1. So that is how you'll do this question. All right, let's call it a day there.
All right, thank you.
See ya.